7, Unit 3, Proportional Reasoning, Lesson 8, Part 1. Direct variation, y equals kx. Two quantities x and y show direct variation when y equals kx. K is a number that is not equal to 0. The number k is called the constant of proportionality. For the graph of y equals kx, it is a line, has a slope of k, and it passes through the origin. So the two quantities that show direct variation are in a proportional relationship. We learned previously that a proportional relationship will graph a straight line through the origin, and a direct variation will also graph a straight line through the origin. A little bit more information though. The y equals kx is the same as y equals mx, m being the slope, k being the constant of proportionality. So if we can find the slope, we can write the equation. And look at all of this stuff that is the same. If I say y varies directly as x, that's the same as me saying y is proportional to x. If I use the constant of proportionality from an equation, that is the same number as the slope from the graph of the same relationship. The rate of change calculated in a table is the same as the slope from a graph. The unit rate calculated from a context is the same as the slope from a graph. All of these things are the same, okay? The constant of proportionality from an equation is the same as what you would calculate in a table as the rate of change. Unit rate from a context is the same as what you would calculate as a rate of change in a table. And the constant proportionality from an equation is the same as what you would calculate as the unit rate in some sort of context. So all of these are related. Okay, we're going to identify if these show direct variation, and we're going to make a graph and then check for two specific things. The first thing is if they graph a straight line. The second thing is it needs to go through the origin. All right, this first one, if we graph them, you can see 1, -2 is this point right here, 2, 0, 3, 2, and 4, 4. It is a straight line for sure, but it does not go through the origin, so it does not show direct variation because it does not go through 0, 0. Okay, the second example here, we can actually see from the table that it goes through 0, 0. It just has to have everything proportional. If we graph these points, you can see that they end up being in a straight line and they go through the origin. So these do show direct variation. They are proportional. And explaining, it is a straight line through the origin. If it's got those things, it's definitely a direct variation. Okay, tell whether x and y show direct variation, explain your reasoning. To determine if an equation represents a direct variation, we just need to be able to write it in the form y equals kx. And another little caveat to that, we can also check to make sure it goes through 0, 0. Because if it doesn't go through 0, 0, it's definitely not a proportional relationship. First, let's talk about trying to put it in this form. Y plus 1 equals 2x. I can go ahead and subtract 1. I get y equals 2x minus 1. 2x minus 1 is not the same as a number times x. It's a number times x and then subtract something. So this minus 1 is a big problem. Proportions are all about multiplication. Nothing to do with addition and subtraction. So no, this is not direct variation because of the minus 1. Can't have the minus 1. Okay. This next one, it does have one number equals the other number times a specific number. So this one definitely is direct variation. If we want it in the form y equals kx, we can multiply by 2 over 1. And we get y equals 2 times x. And then we can see that k is just 2. Now I mentioned a couple of minutes ago that you could also check 0, 0. Now, this doesn't guarantee that it's going to be direct variation, but if it fails this test, it guarantees that it is not direct variation. So we're going to plug in x, 0, and y, 0, and see if these work. So bringing this down, I've got 0 plus 1 equals 2 times 0. 0 plus 1 is 1, 2 times 0 is 0. This is false. So it does not go through 0, 0. That's enough to tell that it is not a direct variation. This other one, if I try plugging in 0, 0, I get 1/2 times 0 equals 0. 0 equals 0. That means it does go through the origin. That by itself does not guarantee that it's a direct variation. But it makes it so all we have to do is check to see if they are proportional otherwise. And since I can solve this one to get y by itself, and it's y equals a number times x, then it's definitely a direct variation. All right, tell whether x and y show direct variation. Explain your reasoning. Now, we could graph it. If we graph it, we're looking for a straight line through the origin, and all ordered pairs are going to be proportional. Now, first off, on this first table, this is 0. It should be 0 here, but it is not 0. So it does not go through the origin. It goes through the point 0, -2. So this one is not direct variation, which again means it's not proportional. So it's not direct variation because it doesn't include the origin. Now the next one, it doesn't have the zeros there, so we can't quickly check to see if it has the zeros, so we're just going to move on and see if the ordered pairs are proportional. Now, ordered pairs being proportional, if I compare 4 to 1, I get 4. If I compare 8 to 2, I also get 4. 12 to 3 is also 4. And 16 compared to 4 is also 4. Every one of these comparisons of y to x gives me 4, which actually, every time you compare y to x, you get your constant of proportionality. So, yes, this is a direct variation. In fact, k equals 4. All right, next one. We check to see if it's a straight line through the origin. One thing I noticed right off the bat, the origin is included. So that looks pretty good. That's actually not enough here. We need to double check and see if the rates are the same. If I try y over x on all of these ordered pairs, 4 over -2 is -2. 2 over -1 is -2. And 2 over 1 is +2. All right, that's a bit of a problem here. It is a different number. It's supposed to be -2, but it ends up being +2. Because this ends up changing its ratio, it is not proportional. So no, let's not call it the unit rate. The ratio changes. In fact, it'd probably be a good idea for us to look at what the graph of this would do. We'd have -2, 4, -1, 2, 0, 0. It's looking pretty good, and then it doesn't work on the next one because it bounces back up. So it ends up not being a straight line through the origin. It does go through the origin, but it ends up kinking at the end there. If this point had been down here instead at 1, -2, then it would be direct variation. Okay, xy equals 3. One of the first things we can quickly check, this, if it fails this test, then we know it's not direct variation. If it passes this test, we got to keep checking. If I plug in 0 for x and y, I get 0 times 0 equals 3. That is false. So this one I would say no, it does not include, let's put does, it does not include 0, 0. So there's no way it could be direct variation. The next one, if I try in 0, 0, 0 equals 1/3 times 0, it passes the first test. So let's investigate further, because that is true. It looks like one of the variables is equal to a number times the other variable. That actually makes it direct variation. We don't necessarily have to put it into the form y equals kx. Right now it's x equals a number times y. We do know it's direct variation because there's only multiplication. In fact, we could quickly figure out that k is 3 because y will equal 3 times x. If x is a third of y, then y is 3 times x. We could multiply both sides by 3 over 1 to demonstrate that as well. Okay, the next one, just for the quick check, let's see if 0, 0 goes into it. This is 1 equals 0, which is false. This is not proportional. It's not direct variation. It doesn't go through 0, 0. Okay? Which means we don't have to check any further. Another thing you might notice here is that addition is involved and proportion should be dealing with multiplication only. There is one situation that I can think of right now where you would have addition or subtraction. It'd be something like this. X minus y is 0. Because if I move it to the other side, I get x equals y, which means they're definitely proportional. But notice if we try a 0 into these, I'd get 0 minus 0 is 0, which is true. It passes the go through the origin test, which remember, going through the origin does not guarantee it's proportional, but not going through it guarantees that it is not. It's not a complete test that way, but it is still useful. Okay, the table shows the area y in square feet that a robotic vacuum cleans in x minutes. Graph the data, tell whether x and y are directly proportional. So we've got the data graphed over here. And just a quick look at that graph. It is a straight line. It goes through the origin. So it definitely shows direct variation. They are proportional. Write an equation that represents the line. All right, for the equation, we need to find the constant of proportionality, which can be found several ways here because we know that the unit rate from the table, h divided by a half, is the same as the unit rate, is the same as the slope. Maybe here we do the slope, it's up 16 and over 1. Either way, we do end up with a constant of proportionality that is 16. So y equals 16x, where y represents the square feet and x represents the minutes. Use the equation to find the area cleaned in 10 minutes. All right, because we are given the information for 10 minutes, and y represents area cleaned and x represents minutes, we're going to make x equal to 10, plug that in, and we get y equals 160. Remembering that y represents square feet, so this is 160 square feet.